Hi M2E. This is page 10 of our packet, and we're going to talk about using synthetic division to help me break down my higher order polynomials. So first of all, let's talk about what a good divisor is when I use synthetic division. My divisor has to be a binomial. A binomial has two terms. So for instance, an example that would be a yes would be like an x plus 3. That has two terms, or an x plus 5. A no would be 2x squared, for instance. That's only one term. Another thing is that the divisor has to be linear. So the divisor has to be linear. So, and one last item is the coefficient on my x term has to be 1. So let's look at my yeses again. Notice both of these are linear. They're both x to the first. And notice that the coefficient on x is 1 on both of them. So is x minus 6. So is something like x minus 1/2, for instance. Let's look at some more no's. Anything quadratic. So for example, 2x squared plus 2 is still a no. There's an x squared in it. It's not linear. How about 3x plus 1? That would be no, because my coefficient of my x term is a 3. It is linear, it is a binomial, but my coefficient's not 1. And same deal with something like 1/2 x squared plus 2x plus 3. That's for sure a no. It's quadratic. So how do we set up synthetic division? Let's take a moment to look at this long division problem. We were working on those in class. It's the page 9 video if you haven't watched it. So our divisor was the x minus 2. The green polynomial was my dividend. That's what I'm trying to break down. And the blue quotient, that's my answer. That's my polynomial broken down. And this is telling me that x minus 2, that's my divisor, times my quotient, x squared plus 5x plus 6, equals my original green polynomial, x cubed plus 3x squared minus 4x minus 12. So what I did is I used my long division to break down my answer, or to break down my original polynomial. So how do we use synthetic division to do that? Well, x minus 2, my divisor, this is a factor. When I use synthetic division, I need to use the root. So if x minus 2 equals 0, then the root is x equals 2. When I use synthetic division, I use the root. So I'm going to use 2, not negative 2. So the root is 2. The factor is x minus 2. So now that I'm using the 2, I go grab the coefficients of my polynomial. So the coefficient on my x cubed is 1. The coefficient on my x squared is 3. The coefficient on my x term is negative 4. And the constant is negative 12. So let me grab my highlighter. I went over here and I grabbed the coefficients in front of my x cubed, x squared, and x, and then my constant. And again, the 2 comes from the root. The factor x minus 2 gives me the root of 2, positive 2. So how do I do synthetic division? It's a process like long division that's always the same. So our first step is to always bring down the first number. And then we enter a pattern. We are now going to multiply this number by my 2 in the red box. So 1 times 2 is 2. Now, at this point, we do whatever our signs say. So we're adding. So 3 plus 2 is 5. And now I'm going to do the whole process again. 5 times the 2 is 10. And now, again, I add. I do whatever my signs say. So negative 4 plus 10 is 6. Now I'm going to do the process again. 6 times 2 is 12. And now I do whatever my signs say. I add, and I get 0. This 0, this last number, this is my remainder after the division. There's a 0 there. If I could draw your attention to the left side, it's the same 0 that's at the bottom of long division. That's my remainder. So how do I write my answer? Remember, when I do division, my answer, which we call the quotient, quotient. I was spelling it wrong. The answer, which we call the quotient, is 1 degree less because I divided it by something linear. So it would go down by 1 degree because I divided by something linear, which is 1 degree. So my original green polynomial was an x cubed. So my answer will be an x squared, and these numbers are my coefficients. So let's start off with the 1. That gives me 1x squared when I go down by 1 degree, plus 5x plus 6. This is my answer, and you'll notice it's the same answer we got when we did long division. Let's do it again. There is a few tricks to keep in mind when you're doing synthetic division. First of all, you have to enter a term for every term in your polynomial, even the ones not there. So let's take a look at this x cubed. There is no x squared. You do need to think about the coefficient on your x squared being a 0. I am going to put the 0 in my synthetic division setup. So now this is my divisor. It's my factor. I need to think about the fact that if I set that equal to 0, my root that that factor gives me is x equals 2. So I'm now going to set it up with the 2 in my little box. I'm going to write all my quotients. So the coefficients. My x cubed coefficient is 1. My x squared coefficient is 0. My x coefficient is 1. And my constant is 10. So now I'm going to start my process. Let me grab a different color here. I'm going to bring down the 1. I'm going to multiply by 2. I'm going to add and get 2. I'm going to multiply by 2 and get 4. I'm going to add and get 5. Lastly, I'm going to multiply by 2. And I'm going to add, and careful, I get 20. This guy is telling me my remainder is 20. So, in other words, x minus 2 is not a factor. So let's write down a few things. Let's write down my answer first. Remember, my degree is going to go down by 1. Your degree goes down by 1 because you divide it by something linear, which anything linear is degree 1. So instead of an x cubed, I'm going to have an x squared. So this is going to be 1x squared plus 2x plus 5. I just kind of go down my exponents, an x squared, then an x term, then a constant term. And my remainder is 20. But we're not in 4th grade anymore, so we're not going to write R20. What we're going to write is that the 20 is the remainder. The 20, when you have a remainder, that has not been divided yet. That's why it's a remainder. There was leftover parts that didn't get divided. So we really write this. I'm going to get rid of the 1. X squared plus 2x plus 5. Now the remainder is going to be 20 divided by x minus 2, my original divisor. The 20 is the part that remains undivided by my divisor, which was x minus 2. You can see that up in the very beginning. That's how we write the answer. This is the answer to the problem. Let me grab a different color. I know some stuff. I know that x minus 2 is not a factor of the x cubed plus x plus 10 because I had a remainder. I also know that x equals 2 is not a root because I had a remainder. It didn't go in evenly. And there's a third thing I know, and I've ran out of room, so I'm really sorry about this. There is something else I know. I'm going to talk about it more in a minute, but it's synthetic division is sometimes called synthetic substitution, because I also know that P of 2 equals 20. And I'm going to talk about that a little bit later in this video. So if you give me one moment, let's do 2, and then I will come back to this idea of synthetic substitution being equal to whatever the remainder is. So let's do number 2, and when I'm looking at 2, don't let this 3 in the front throw you off. I'm okay with the coefficient being on my polynomial. I just have to make sure that my divisor is linear, it's a binomial. So in this case, x plus 2 is my factor. So my root, when I set this equal to 0, I get x equals -2. That's my root, and that's what I use in my division. So I'm going to start off with my -2. I'm going to write all my coefficients. You'll notice I'm not missing any terms. There's an x cubed, there's an x squared, there's an x, and a constant. So I'm going to put my 3 for my x cubed, my 8 for my x squared, my 5 for my x, and my -7 for my constant. So now I start my process. Let me get a different color. I'm going to bring down the first number, 3. I'm going to multiply and get -6. I'm going to add. I'm going to get 2. I'm going to multiply and get -4. I'm going to add and get 1. I can already see this is not going to work out. I'm not going to get a 0 for remainder is what I mean. 1 times -2 is -2, and I get a -9. Remember, this last number is my remainder. And we're going to write my answer. We're going to go down a degree. So my first term will be an x squared term. So I have 3x squared. My next term is an x term, so 2x. My last term then is the constant. And then now I'm going to add my remainder divided by my divisor, which this case was x plus 2. If you want to write minus and then a positive 9 over x plus 2, that's okay too. I'm just used to doing plus my remainder over my divisor, but all the same. So some stuff we know here is that x plus 2 is not a factor, simply because the remainder wasn't 0. I know that -2 is not a root. It's not an x-intercept. It's not a solution, simply because I had a remainder. And now I want to talk about the synthetic substitution. So if I think about p of x equaling that original polynomial, 3x cubed plus 8x squared plus 5x minus 7. If I substitute in a -2 for x, I would have 3 times x times -2 cubed plus 8 times -2 squared plus 5 times -2 minus 7. And I'm not even going to do any work. I'm not going to put anything into my calculator because guess what? I already know that answer. That answer is -9. So let me go back to the problem that I had before where I was running out of room. So I'm writing in blue. This is for number 1. And I ran out of room. So remember, this is going back to number 1 on the left side. So I know that if p of x is equal to x cubed plus x plus 10, and I realize I'm running out of tons of room here, that if I substitute in this case, my synthetic division was done with a positive 2. If I substitute a positive 2 in, I would have 2 cubed plus 2 plus 10. And I don't even need to grab out my calculator. I know that answer is going to be 20 because that was my remainder when I did my division, my synthetic division. So let me grab out my highlighter. Some important things to note. This divisor, x minus 2, x plus 2, x minus 5, x plus 4, it's only a factor of the polynomial if there's no remainder. Your remainder is 0. And this x minus or x plus the number is a factor if and only if the remainder when you do your division is 0. And that means when you substitute the number into the polynomial, you'll also get an answer of 0. So let's go, if you'll notice, I squeezed the next 2 statements in up above. So if I could move my paper up, sorry. Right here, this is the substitution we did right there. And then you'll see this one is the one I did in red right here. Sorry about that. And now let's go back up to our intro example when we very first started at the top of the page. My divisor was x minus 2. That means that my root was x equals 2. You'll notice that's what I used in my synthetic division. And so if my polynomial was my original polynomial of x cubed plus 3x squared minus 4x minus 12, and I substituted in a 2, I'm going to get 0. Because that was my remainder when I did synthetic division. Let me erase that so I can make it really clear, you guys. If I took a moment and I did 2 cubed plus 3 times 2 squared minus 4 times 2 minus 12, I would get 0. That's what synthetic substitution is. And it has the same answer I get when I do synthetic division. They go hand in hand, and they're very useful tools as we move into higher mathematics. Thank you.